Okay, so children, today we will be doing a little bit different in terms of the lesson. All right. Um, oh no, math exam tomorrow. Cry my heart out. Yo. All right, so we will be doing a little bit different here. Okay. So I will go through last week's homework first. All right, which I'm trying to catch up every week. Right, because there's just too many things to teach. All right, and uh those students who ask me questions, all right, you all actually message me saying that you don't know how to do certain question, and you actually let me know that you are weak in certain topics, all right? So we will be actually doing some additional questions out from the worksheet, right? So if you have any questions that you don't know, you can actually kind of WhatsApp me lah, all right? Then if there's time, right, we'll try to discuss in class. All right. So later we are going to do a bit of the graph work, quadratic graph. We'll be going to do a bit of the other school exam paper also. All right. So if you can message me telling me what your problems are, I can try my best to help you as best as I can. Cool. All right. So let's not just talk too much already, because usually when I talk, right, yeah, I can just go on and on. Okay. So let's go into this portion, all right, which is your work from previous week, right? The homework from previous week. All right, so can we just quickly run through these questions? Okay, let's go. So ABC is a triangle. All right, ABC is a triangle. ABC is a triangle. AC is 13. Children always read the paragraph and look at the diagram. BC is 11. AB is 20. N is a point on BC, produce. What's the meaning of BC produce? Means BC is down here. This is BC. Produce, put. All right. Means is what? It's 180 degrees down here. All right. So the meaning of produce means it's a straight line that is coming out. All right. A straight line that is branching out. Where CN is 5 cn, 5 cm, AN is 12 cm. The diagram is not drawn to scale. Obviously, it's not drawn to scale. All right. It looks so not correct also. Find angle A and B. Where is angle A and B? A and B is down here. All right, angle blue. Is that okay? All right. So for those who don't know where this question is found, right, it's actually from the previous worksheet, worksheet 36. All right. So worksheet 36, there's a few questions as homework that we haven't complete. So I'm trying to complete those questions before going to worksheet 37. Hello, Chen Feng. Hello, the rest. All right. Hope you're good. Okay. So what should I do? All right. I need to find angle A and B. Okay. So one thing, right, I need to take a look is this portion of the triangle. Very irritating. Very irritating. What's so irritating? I look at the numbers 5, 12, and 13. All right. Do you know that 5, 12, and 13, right, is actually a magic number? All right. Magic numbers for what? For a right angle triangle. Do you know that? All right. It's actually for a right angle triangle. Very irritating. All right. It doesn't even look like a right angle triangle. I totally agree. That's why the question say not drawn to scale. Can you see now? So I believe many of you, right, remember the 3, 4, 5 triangle. Okay. So this is like 3, this is 4, and this is 5. And when you see 3, 4, 5, 3, 4, 5, 3, 4, 5, it's what? It's a right angle triangle. Right. But I need you to memorize another set of number, the 5, 12, and 13. This is also a right angle triangle. All right. So again. All right. How do you prove that it is a right angle? So for example, all right, if the question gives you something like this, all right, let me draw out for you. If the question gives you something like that, just a quick revision on how to prove a right angle triangle. If this is a 5 and this is a 12 and this is a 13, can? Okay. And down here is, for example, a CN, and down here is a A. Okay, so remember, proving right angle triangle, you have to use something called Pythagoras theorem. Okay? So for example, the question asks you to prove this A and C, is it a right angle triangle? What are your steps? All right, remember the steps, please. Okay? So usually I'll start off with a short square. I will say that NC squared plus NA squared is equal to, wait for it, you put in the numbers. All right, NC squared is 5 squared plus NA is a 12 square. All right, and you work downwards like that. Remember the format, please, children. Remember the format. Equal to 169. And 169 is actually a 13 squared. Do you know that? Of course you know. And 13 actually represents AC squared. Can you see that? Then down here you can say, therefore, by converse of Pythagoras theorem, remember this? Right? Of Pythagoras theorem. All right, what can you say? All right, you can say that NC squared plus NA squared is equal to AC squared. All right, so you're proving right angle triangle. Must say the word by converse of Pythagoras. Then down here you can say that with angle A and C as the 90 degrees. Can you see that? So children, this is the format for proving right angle triangle. This is the format for proving right angle triangle. Can? So this number 5, 12, and 13 is actually the magic numbers that forms a right angle triangle. So this is actually 90 degrees. Sure, doesn't look like, I know. But the question did say, diagram is not drawn to scale. So you're supposed to learn to recognize the numbers, children. You know what's the meaning of recognize, right? So for example, you see, I mean, your parents, right? They may have a walking style, right? They walk maybe swinging their arms and all this. So from far, far away, this person looks very familiar. So in a way, you recognize them, all right? So you don't really know it's them. You don't really confirm it's them, but you kind of recognize, it looks familiar. So the same thing is down here for numbers, right? I need you to recognize those numbers so that, this one looks familiar, right? 5, 12, 13. All right, so the more common number is 3, 4, 5, 5, 12, 13. These are the two main common number, Larissa, all right? I can only think of these two right now. All right. So later, if I think of another set of number, I'll let you know again, Ken. All right. But these two are very, very popular numbers. Okay. So once you can get this as a right angle triangle, right, then you can actually go and do your next step. All right. Which is what? Finding A and B. All right. A and B. A and B is what? 90 degrees, correct or not? All right, I just proved that it's a right angle triangle. So after proving that it's a right angle triangle, I can say that it is 90 degrees, correct or not? Chair. All right. So part B1, all right, this type of question, when there is a right angle triangle, I did told you, right? Whenever there is a right angle triangle, right, what do? Please automatically activate two rules. Number one, Mr. Pythagoras. All right. So Pythagoras theorem states that what? States that A squared plus B squared is equal to C squared. All right. And number two, remember trigo, tua, ka, so. All right. They are the hidden formulas within the trigonometry ratio. Can? Okay, come. Express your answer as a fraction. Your answer must be in a fraction. All right, question say, all right, in the simplest form for tangent ABC. All right, tangent ABC. Where's tangent ABC? So you mark the angle tangent ABC is down here. ABC down here. Sure, this triangle very ugly. I know. I know. All right. So down here, right? Let me draw out. Let me draw out to make it less ugly. All right, because sometimes it's very hard to visualize if your diagram is not clear, right? So what do? All right, use your own initiative. Just now I was teaching my primary 3. All right, use your own initiative. Don't wait for things to happen, children. Don't wait for things to happen. All right, so sometimes we need to take an initiative to do it. Let's do it. You see? Like that better? And you're supposed to look for this angle down here. So down here we have 5 plus 11 to give us a 16. Down here we have 20, and down here we have 12. Right? So we look at the big triangle. We can erase away this line. Can you see? So in order to find tangent ABC, all right, or ABN, what do you need? All right, the 90 degrees is down here. Remember, do what? Do what? This is the angle you want. This is called the opposite. All right, the opposite and the adjacent will form the 90 degree, which means that this is hypo. And remember, hypo is always opposite the biggest angle, which is 90 degrees. Can? Caitlin, thank you so much. All right, your exam is on 9 October next Monday. Oh, our lesson is on Tuesday, so next Monday. Yeah, I think we will miss that already. Okay, come. So moving forward. What is tangent? Tangent is toa, right? So you write out the general formula. Tangent theta is equal to opposite over adjacent. And our focus is on which angle? Angle ABC, right? Opposite is what? Opposite is actually 12 and adjacent is actually 16. The question wants it as a what? As a fraction. All right, so you give it as 12 over 16, but please remember to reduce to the lowest term. Divide by 4, divide by 4. Answer is 3 over 4. Right, leave it as a fraction. Don't do extra. Unless the question asks you to find what? What is angle ABC? All right, if the question asks you to find angle ABC, then you have to do the extra step. Do you understand? All right, so if down here the question asks you to find angle ABC, I want to find angle ABC. What do? The tangent you have to bring across. So when you bring the tangent across, will be tangent to the power of -1, 3 over 4. If the question asks you to find angle ABC, then you got to press your calculator. All right, so when you press your calculator, shift tangent 3 over 4. If the question asks, right, your answer will be 36.869 degree, 1 dp, 36.9 degree. Then declare 1 dp. If the question asks to find angle ABC. But the question did not. Question asked you to find tangent ABC. So children, don't give extra. This is the answer. Understand or not? So you have to answer specifically to the question. Don't give extra. Can? And the next portion, we are looking for cosine ACB. Okay, this one is difficult. Right, this one is only taught to some of the schools, which are maybe in the IP and all this. All right, so just something different. All right, if you're not learning this, it's perfectly okay. All right, ACB is here. ACB is down here. This is the purple angle. All right, so every time I look for the outside, right, this purple angle is like outside the right angle triangle. Can you see that the right angle triangle is actually this blue color portion? All right, so this is the right angle triangle that I have information about. All right, so this inside angle, we call it inside. But the purple is not inside. The purple is outside of the right angle triangle. This is called outside. Okay, or to be more precise, we call it the obtuse angle. All right, the inside one is called the acute angle. Small, cube. So question is looking for cosine outside, you know. All right, if the question is looking for cosine outside, right, which is the purple angle, so ACB is the outside, right? This is the outside, can you see? The purple. I'm trying to keep my color consistent. Don't be afraid. Don't be afraid. All right, cosine outside is actually equal to cosine inside, which is angle ACN. All right, I have thought about this before. However, it will not be tested. Don't worry for most of you. All right, but if you're in the IP program, this one you need to know. All right, so cosine outside is actually equal to cosine inside. But remember, there is an extra minus sign for cosine. All right, I taught this before when I'm teaching the trigo. But if you don't understand, it's perfectly okay. All right, it's perfectly okay because it's not in your syllabus. All right, don't worry so much. All right, I'm teaching extra because there are some people who are in the IP program. Okay, all right, so let's go and find the cosine inside first. All right, so what's the meaning of cosine? Cosine theta is equal to adjacent over hypo. All right, and we are looking for cosine ACN. So cosine ACN is equal to adjacent. Where is the adjacent? This is called the opposite. This is called the adjacent. And this is called the hypo. All right. And the hypo we know is 13 cm.